Here I'm shown a variety of functions, these rational functions, and we're told to find the horizontal asymptote for each one. And what I'm going to do to buzz through these really quick is briefly categorize them according to three different ideas: top heavy, equal weight, or bottom heavy. And what I mean by that is a comparison of the factors of x on top and bottom. Let's use this first one as an example. There are two factors of x here, right? If you were to FOIL that out, you would get some kind of an x squared. You'd get like negative 9x squared, blah, 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 blah. It's not important. The important part is it's a squared. There's two factors of x, and that's weaker than what you have on the top. On the top, we only have one factor of x. So this one we would call bottom heavy. The next one, bottom heavy, same reason, right? You've got an x squared on bottom and only a value of 1 on top. The third one is equal weight, because we have a negative x squared on top, a 10x squared on bottom. You might think that the 10 is stronger than the negative 1, but that's not the case. We're looking at exponents, okay? I only want to focus on the exponents when I determine if it's equal weight or bottom heavy or whatever. The next one, also equal weight, right? They're both x. And the next one, also equal weight, right? It's two factors of x on the top, two factors on the bottom. This last one in the list is top heavy. And just, this kind of went in a nice order. It won't always be that way. This problem rotates around. Now, we've categorized all these equations. I want to just make some horizontal asymptotes. The bottom heavy ones are very easy, right? Y equals 0. Anytime it's bottom heavy, your horizontal asymptote is just y equals 0. That's it. You're done. Now, a top heavy one is also very easy. There is no horizontal asymptote. It's just a D and E. That's very quick to solve. There's a different kind of asymptote which we haven't talked about yet for these scenarios. That's called an oblique asymptote. It's like a diagonal asymptote, but we'll get to that later. Now I want to talk about those equal weight asymptotes. For these guys, remember, we're doing ratio of the leading coefficients. So in this case, now I look at that negative 1 and the 10. So this would be y equals negative 1 over 10. Okay, we've gone over some more of the theory reasons for this in class. I'm just giving the quick and cheap way to calculate these right now. In this case, it's negative 2 over 5. And in the last case right here, well, we might have to do a little bit of work. We have to figure out what the coefficient is. And I think it's going to be a negative 2x. I'm calculating the power function right now. Negative 2x times x and 2x times 4x. Did you see where those came from? There's the negative 2x, there's the x, there's the 2x, there's the 4x. So when you work those together, you get a ratio of the power functions, which is negative 2x squared over 8x squared. So our leading coefficients are negative 2 on top and 8 on bottom. And you can say negative 2/8 if you want, or negative 1/4. It's the same thing.